good morning, afternoon, or whatever time it may be where you are at. In this video I will be discussing the Dungeons & Dragons Weapon Simulation Statistics Lab. I will be providing tips and tricks to help you complete each section of this lab. So let's get into exactly what is going on. As your group of adventurers travel along the path towards the caves of Dumboro, you hear cries for help coming from the thick forest to your right. You follow the sounds to discover an elderly woman in a finely embroidered purple cloak, grasping at her leg. Upon further investigation, you notice the woman is snared in a bear trap. Upon releasing the woman, she offers you a choice between 5 weapons. The weapons are Link's missing sword, the I can't believe it's not better knife, the pickled spear, the cowboy's quarterstaff, and the Knott's old great axe. The weapon's attack power is listed below. You must use statistics to decide which weapon to choose. The objective for this lab is that you will perform chance experiments and run simulations to determine which is the best weapon to choose. The weapon choices, again, are Link's missing sword that has an attack of 1d10 piercing. The I can't believe it's not better knife has an attack of 1d4 plus 3 piercing. The pickled spear, which has an attack of 1d6 plus 2 piercing. The cowboy's quarterstaff, which has an attack of 1d8 plus 1 bludgeoning. And the Knott's old great axe, which has an attack of 1d12 minus 1 piercing. Now you may be asking yourself, what does this 1d10, 1d4, and 1d6 stuff mean? Okay, so the D represents the dice. The number that comes after the D is the number of sides on the dice. The number that comes before is how many of those dice you are throwing. So 1d10 means that you are throwing 1d10 or 1 10-sided dice, and whatever result you get would be the result for your attack. For the I can't believe it's not better knife, you notice it's a 1d4 plus 3. So you will throw a 4-sided die, and whatever result you get on that, you will add 3 to it, and that will be your damage. So on and so forth as the other ones show. The first section in this is to create a sample space for each weapon. This meaning that you are going to list every possible result from rolling the die. So, for this situation, let's say we're using Link's missing sword. Okay, we have in this a 10-sided die. So on that 10-sided die, you have 10 possibilities. You may roll a 1, a 2, a 3, 4, 5, 6, 7, 8, 9, or 10. Alright, so this is your sample space for Link's missing sword. Everybody's sample spaces will be the same for this. Okay, but each different weapon has a different sample space. The next section is about the classical probability approach. So with this, you are going to take your sample spaces and enter them into the calculator to get a mean and standard deviation. Now, since this is the entire set of possible outcomes, we're going to use the population characteristics because that's every possibility that we would get from it. Now, before we actually do this, in our calculator, some of the things that we're going to use later on, we'll be using a lot of memory for it. So, some of these calculators have been running for a while, and the memory has been used up for a bit. So, what we want to do is we want to clear that by doing second plus 712. Now the problem with this is that it resets your calculator all the way back to the beginning. So one thing that does happen, since we're going to be using random number generators for this, we need to actually adjust some things on this. So we need to actually enter in some random digit so we can set our random number generator stuff to start at a different point than what would be default on the calculator. If you don't do this, everybody is going to get the same results. Okay, so all you're going to do right now is just enter in some random numbers into your calculator as I'm showing to the left. After that, you hit the stow button, which is left of the 1. We go to math, we go to probability, and we're going to do the first one, random. Basically what this is going to do is going to change the random table to a different position than the default first position. Okay, so whenever you do a random number generation, it's going to give a different value. Now this does not technically play an effect on section B, but it will have an effect whenever we get to section E. So now that we're on section B, we're going to end up doing the same thing, but we're going to figure out what these values are using one variable statistics and our lists. So the way that we're going to do this is we go to stat, we go to edit, and we're going to type in the sample space. So we're going to use Link's Missing Sword for this one. So I'm going to type in 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so those are all the values. Now say you missed one of these, you can go back to it and enter in. Or say you entered in something an extra time, you can go to it and you can hit delete. So say I'm going here, I didn't want this 5, I could just delete it. Notice it disappears. However, I do need that 5, so I need to actually put it back in. So I'm going to do second insert and put in another 5. Notice it replaces it and actually shifts everything down. Okay, so now we have the list that is the entire sample space. We're then going to create or calculate the mean and standard deviation using one variable statistics. So in order to do that, we go to stat, we go to calculate one variable statistics. We're going to use L1. So in some calculators you won't get to this nice fancy screen. If you get to one that just says one variable statistics, you'll then have to type L1 afterwards and hit enter. This will end up populating a screen like this. Notice the mean, we don't have the mu there, we have the x bar, but it's the same thing for this. So in this problem we're going to have the mean of our graph being 5.5. Now the standard deviation, when we are doing this, we are going to end up looking at the population standard deviation because this is the entire set that we could get, so it's the population from it. So this ends up giving us a value of 2.872. Now you would repeat the same process for the I Can't Believe It's Not Better knife, pickled spear, cowboy's quarterstaff, and Knott's old great axe, but just using those sample spaces. Is the experiment portion. So in this one we're going to actually use physical dice to roll 5 times for each weapon and list the damage dealt. Now if you're using Link's Missing Sword, you're going to roll the 10-sided die and that will be your damage, but again if you roll the I Can't Believe It's Not Better knife, whatever result you get on that 4-sided die, you have to add 3 to it. Now I'm going to just do an example for the Link's Missing Sword. Yours is going to be different because you're going to do your own. So whenever I'm rolling for my Missing Sword, I first rolled a 2, then a 9, then a 4, then a 7, and then an 8. So those are my 5 rolls. After you do that for each of these weapons, you then move to the statistics for your experiment, which means that you're going to actually calculate the mean and standard deviation for each weapon using the sample space that you had before from the ones that you rolled. As we go to our list, we're going to enter in our data. So we're going to clear off this one, and I'm going to type in the results like stat, calculate one variable statistics, L1, calculate, and I will get my results. So for this problem, I ended up getting that my mean from the ones that I rolled was a 6. So that's x bar. My standard deviation I'm going to use the values here with the S, not the population one, and I will get that as 2.915. So on the next page, you're going to be asked to repeat the previous experiment for 10, 50, and 500 rolls. Now, if you were actually trying to do this with a set of physical dice, it would be very time consuming, so you don't want to do it. So instead of doing that, we're going to actually use our calculator to make a simulation on it. Okay, so for this one, so I'm going to look at the I Can't Believe It's Not Better knife for this situation because it offers some extra things that you can do. Now, it still works the same way, but when you're entering things into the calculator, this will be helpful for it. So, for the I Can't Believe It's Not Better knife, I'm going to go to my stat, I'm going to go to edit, I'm going to go ahead and clear off this first one, and I'm going to highlight the top portion. So notice that I have the top portion highlighted. So the I Can't Believe It's Not Better knife, say I want to do it 10 times. Okay, I'm going to have the top portion highlighted. I'm going to go to math, probability, and random integer, the fifth one. So the values that I can get from here would be a 1 or to a 4. Okay, so if you have this the newer updated calculators, you're going to see a screen like this. So you will end up typing in the lowest is 1, the upper is 4, and we want to do this 10 times. So the next number would be 10. We're going to use it to type paste. Right. Notice what it comes out in here, it says random integer parentheses 1, 4, 10. So that means those numbers that you're going to get is 1, the highest number you're going to get is 4, and you're going to do it 10 times. Now, if you didn't have that fancy little script there for it, you just type it in exactly like this says. So the lowest number, the upper number, and then how many times you want to repeat. Now, the good thing about this is you can actually go ahead and add in the 3 to all of your values. So again, we got this list here that's going to give us 10 numbers. We can go ahead and say plus 3 to it. Now, if we were just doing the links missing story, we wouldn't have to worry about the plus 3 or anything. But when we do this, we just hit down, and it's going to populate 10 random throws for us. Right? So we're not going to spend all this time actually copying down each of these ones, because we don't want to list 500 things for 5 different items. Okay. And again, your values aren't going to just build off of each other. You're going to just do re-rolls each time to make it a lot easier on yourself. Now, what that means is we're going to move to the next slide and actually use this data. So, on the next slide, with this one, I've got my 10 numbers. First column in this table, I'm going to end up using the data that I got from the actual rolling of the die. So everything in the top in the first column for the 1 to 5 is the ones that we get from the actual rolling of the die. The columns afterwards are we're going to use the simulations for. So I'm going to go to my simulations here. So after I have all the data done, I'm going to go to stat. I'm going to go to calculate one variable statistics, L1 again. Again, if you put it in a different column, you can do it that one. Right, and then I get my results. So in my X bar for here, I'm going to put for 10, 5.9. Now, the mean that I would get is the actual result from section B. So whatever I got in section B would go here. Right? So it just depends on whatever result you end up getting. Right? Now, for the next line, you're going to just do what it says here. You're going to take the X bar that you got here and subtract the mean from section B, and if it was negative, you just drop the negative. If it's positive, you keep the number the same way. Now, for the next step, you're going to use the S from the calculator. So So in this situation I got 0.9944, and we're actually going to copy the actual population statistics here as well. So we're going to do the population standard deviation as well, just because there is a method that we will look at later on. So notice we're going to go here and also copy 0.943, and this rounds up to 4. Alright, so the last line on here, we're going to do the difference between the two. So the difference between the two will be 0.051. Right, and you get different results. But again, I want 4 digits for these. That helps with it. Alright, so after you finish all of these tables here, you then will move to the next page, which is going to be where you're going to do some data analysis on the values. So the first question says, what happens in simulations means as the number of trials increase. You're going to explain your answer. Second one says, what happens is calculated sample standard deviation compared to the calculated population standard deviation as the number increases. So that's what we just actually ended up showing here. So we're going back to these problems, and we're going to look at the lines here. As it increases, what happens to those values. Okay. And then we're going to actually continue moving on, and the next question says, the trend in questions 1 and 2 is a demonstration of what property of statistics. So there's a specific name here that you'd actually end up having to look at and work through it. Number 4 says, using the data from the 500 trials, what is the probability that a person will average more than 7 damage with each weapon? We're going to use the normal CDF, so the proportion underneath a normal curve, or the bell curve, with this, where the minimum is 7, the maximum would be 1e to the 99. Then you have whatever your mean is, which it would be x bar, and then whatever your statistical standard deviation would be, which is the s. Again, I put the formula there so you can kind of see which one you'd use. You use that and calculate the values for all 5 weapons. Right, again, this is the probability that would end up occurring. You do the same thing for the probability that you would average less than 5 damage using that weapon. And then you're going to be asked which of these weapons has a chance to deal the most damage, and which weapon offers the most consistent damage. And at the end, there is a conclusion. Read through the concluding statements and make a decision based off of your statistical stuff. Again, you want to make sure you include actual evidence with the statistics that you've collected. So again, this is the Dungeons and Dragons Weapon Simulation Statistics Lab. Again, do the best that you can on it. If you need to rewatch this video to find any missing parts, that's perfectly fine. But again, good luck and enjoy the lab.